All right, class, here we're looking at improper integrals, section 3.7. And the first task is looking at an improper integral defined where we have two endpoints, a, in this case t. It's similar to having a definite integral from a to b, except we have an integral from a to t, where here t we can take as an endpoint that is a variable that can change. So here t is, say, some fixed length, and then it gets further, and then further away from A. So we can treat this upper endpoint as a variable, and that variable can go to any distance that we want. And in the limiting case, we could have that t go to infinity. So if f is continuous on some closed interval a to b, or a to t, so to speak, we could extend that t to plus infinity. To do this, we would have to take the limit as t goes to infinity. So each definite integral is really from a to t, but we're taking the limit as t goes to infinity. Now this will be the integration of an improper integral where the upper limit is infinity if the limit exists. So this is technically, this integral here from a to infinity is really the limit as t goes to infinity, provided the limit exists. Of course, similarly, you can do the same thing having t to b, where you extend t to minus infinity instead. So if this integral exists, it exists if this limit exists as t goes to minus infinity. So we can have an improper integral on the upper limit as t goes to positive infinity, or the lower limit as t goes to negative infinity. In each case, we call these an improper integral, and in each case, if the limit exists, we call it, or it's said to converge. If it doesn't have a limit that exists, it says it diverges. So either it has a limit and we call it converging, or it doesn't have a limit and we say it diverges. Okay. Of course, you can combine the two. You could have the upper limit go to positive infinity and the lower limit going to negative infinity. Then you just simply break it up as two integrals. Let's say from 0 to negative infinity on the left and 0 to positive infinity on the right. Of course, it doesn't have to be at 0. You could break this up to any intermediate value here. It could be 7, 10, negative 16, etc. But in either case, you have two different improper integrals that you have to find limits to. Here there's a lower limit as t goes to minus infinity. Here there's an upper limit as t goes to positive infinity. And both of these limits have to exist for the entire improper integral to have a convergent value. Okay, so both of these limits have to exist, meaning they converge for the entire improper integral when I have minus infinity to positive infinity, having that integral converge. All right, let's look at some specific examples.